Jurassic Park will be reopening and needs a monorail system to transport visitors in and out of the park while also transporting baby dinosaurs to the visitor center's petting zoo. The vehicle will need to be energy efficient and cost effective due to the park's location on an island that had limited power. The vehicle will be required to move forward and backward along the track with stopping points and cargo pickup locations. The vehicle will need to simulate the movements and functionality of a realistic monorail car while still providing a safe and comfortable mode of transportation.
This species of variformin's been extinct since the Cretaceous period. I mean, this thing isn't one of this thing. What?
How'd you do this? I'll show you.
I wonder, how many videos do you take? Jeez, I'm the videographer for the group, not you.
Are you covering up your face?
I am.
You realize we're making a video. I designed this to have one motor pushing the AEV towards the rendezvous point of the baby dinosaurs, and two motors pushing the AEV back to the starting point. Mine was designed to look like the dinosaur's mother, with a pterodactyl beak at the front.
And the group decided it failed.
My design had the AEV mounted vertically. It used 3 engines, 2 specifically for forward motion and 1 for reverse. My design uses a concept of a nozzle to increase the efficiency created by the propellers. My design was too hard to build, and the cost would have been too high.
And the group decided it failed.
Stand by. Stand by.
My design was motivated by the concept of balance. It had the motors in equal distance from one another and the battery and the Arduino centered to increase stability. My design is very similar to the sample AEV.
And the group decided it failed.
Nice.
My design was for the AEV to be mounted on a vertical plane focused on the forward and backward propulsion so that the vehicle moved more efficiently. This design also minimized the weight, which increased efficiency.
AEV, I choose you.
This design was created to limit the weight of the AEV. The design was first created with stock parts. Then the design had a custom hull but used the original hanger. Then the final design combined the hanger and the custom part. Each time the group changed designs, the weight of the AEV decreased. This design uses one motor for exclusive forward propulsion and the other for backward propulsion.
Through testing, the group found that this configuration led to the highest efficiency.
Connor, you can't throw the main switch by hand. You've got to pump up the primer handle in order to get the charge. It's large, flat, and grey. Now, under the words contact position, there's a round green button which says push to go.
Testing was the most important part of this lab. This is where the group figured out how the AEV worked under different circumstances. Through the testing, the group discovered that cutting just 11 grams of weight from the AEV, its energy efficiency increased by about 11 joules. Running multiple tests in each lab allowed the group to create a code and fix the errors in the AEV's design.
In conclusion, the project allowed the group members to get a better understanding of how real-world engineering projects work, along with all the choices, stages, and methods that go into them. The AEV fell 4 times. 2 were caught, 2 were not. Only once a screw was broken, and with one of them, a life was taken.